Hmm. Hello, students. Welcome to the first live session for the Introduction to Machine Learning NPTEL course. I'm Rajvi Jain. I am pursuing my PhD in IISc and I'm a PMRFTA. Today we'll be talking about, we'll do one practice problem from week 0. Um, so some administrative things. So whatever is written in this will be made available in PDF format. So make sure you focus on problem solving rather than note taking. Um, uh, this session is being recorded, so you can view it later. And so PMRFT is basically what we do is we generally do some sort of problem solving, interactive problem solving. So you can ask us any doubts and get clarified. We'll try our maximum to get clarified. If not, we'll refer you to the right person or the right book. I will also monitor the discussion forum to see if any doubts are being raised. So my sessions will be on Saturdays from 4 to 5 p.m. Also, another thing is I cannot actually see the Google Meet, chat box as such. So if you have any doubt, please feel free to raise your unmute yourself and ask me any doubt you have, right? Okay, with that we'll go to the first problem of the session today. So so the question is that we have a medical company which touts this new test for some genetic disorder. So false negative rate is smaller is if you have a disorder, the probability that the test returns a positive result is 0.999. Okay. Then the false positive rate is also small. That is, if you don't have a disorder, the probability that the test returns a positive result is only 0.5, 0.005. And I think we have 2% of the population has a disorder as the assumption. If a person is chosen uniformly from the population, is tested, and the result comes back positive. So the test result is positive. What is the probability that the person has a disorder? So in such questions, in probability questions, it makes sense first to understand what events you want to define and try to understand what sort of probability you want to compute. So let's first define the events itself. So plus, I will define it as, let's say I'm getting a positive test result, right? Similarly, minus would mean it is a negative test result. Sorry for the horrible handwriting. I'll let me know if something is unclear. Let's say D indicates that the person has disorder. Okay, so this is the event that the person has disorder. D bar is person not having disorder. Okay, this genetic disorder, whatever we have. All right, so does anyone want to understand, want to tell me what is the probability that you want to compute? So probability that the person has the disorder, but what is it in terms of these events that we have written till now, right? So if you see about it, we have some information already being given, right? We have been told that the person is chosen uniformly and the result comes back positive, right? So under this positive test result, what is the probability that the person has a disorder? So we'll need actually probability that the person has a disorder given I have a positive test result, right? Now conditional probabilities of this form can be expressed, right, using Bayes rule. So anyone wants to tell me what the Bayes rule for this sort of a expression would be? So it would be P of plus given D into probability of D divided by probability of plus, right? So this is according to Bayes rule, right? All right. So let's see what all data we have. So what is probability of plus given D? So if the person has disorder, what is the probability that you will get a positive test result? So that we already have. If you see here, if you have the disorder, the probability that the test returns a positive result is 0.099. So this value as such, one second, yeah, so this value as such is known. So this is 0.999. This is 0, huh? Yeah, right. Now what is probability of D? Probability of disorder, right? Now we have what they have said. They have said we will choose a person uniformly uniformly, right? So therefore, and we have assumed that 2% of the population has a disorder, right? So therefore, the probability of disorder, there is a probability of choosing a person who has a disorder, right? This would then become 0.02, nothing but 2%, right? What we don't have is this, right? P of plus we don't have. We don't have any indication here of what is the probability of getting a positive test result alone, right? This is if you have a disorder. So that is probability of P plus given D. We need probability of plus, right? So what we'll do is we'll basically invoke invoke something called as the total so total probability so total probability, right? If you remember, so this is basically probability of A is summation probability of A given Bi into probability of Bi. Let's say I goes from some 1 to small n or whatever, such that Bi intersection Bj is equal to phi, and union of I equal to 1 to n, Bi is a sample space. So that is basically all the Bi's are forming a partition, is a partition, right? Now using this concept, if you think about it, any event, let's say E and E bar, right? E is a partition, right? Why? Because E intersection E bar is always phi, that we know, and E union E bar is always going to be the sample space, right? Because of the way E bar is defined in the first place, right? So okay, so now what I can do is I can write probability of plus, that is P of plus, as P of plus given D into probability of D plus P of plus given D bar into probability of D bar, right? Here D and D bar, so this is D, let me use, so this is D, and D bar is your partition set, right? Is your partition, right? So now with this in mind, so what we can do is, if we plug in this plug in that here, what we get is so probability of we wanted probability of D given plus, right? So probability of D given plus is probability of plus given D into probability of D divided by, so this becomes now probability of plus given D into probability of D plus probability of plus given D bar into probability of D bar, right? Now what's probability of plus given D? We know this, 0.999 into 0.02 divided by 0.999 into 0.02 plus, right? Now, how to understand, how to get this probability of plus given d bar, right? Any ideas? So if you see here, what we're saying, if we don't have the disorder, the probability that the test result turns a positive result is only 0.005, right? Which is exactly what this event means basically, right? So probability of plus given d bar, right, is basically just telling you if you don't have a disease, still the test will give you a positive result 0.005 number of times, right? So this becomes 0.005 into what is probability of d bar is just 1 minus probability of d. Probability of d is 0.02. So this becomes 0.98, right? Now you can use your calculators or whatever, you will get this to be a 0.803, right? So the right answer is basically this one. All right, so yeah, so this is one question that we have. Any questions as such, you can ask now. Otherwise we'll close the session. So yeah, so anything else you want to ask, you can ask here. Previous week's assignment questions or any conceptual doubts, etc. I'll try my best to answer, and in case I'm not able to answer, I'll make sure that you're directed to the right resource or the right person. Yeah, okay, so let's close the call right now. All the best and see you next week.